Okay, in you go. Take your hats off. Good morning, Year 8. Okay, write down the answers to these, please. Yes, Daniel.
What time are we going to come back from the exhibition?
3 o'clock. First one, 9 sevens, 3 eighths, 32 divided by 4, -6 plus 9, 3 times -9. A mathematical formula for the mean. A formula for the area of a circle. Simplify 4x all cubed. And 3/4 of 16. Here are your answers. 63, 24, 8, -6 plus 9, +3. 3 times -9, -27. Formula for the mean, sigma fx on sigma f. Area of a circle, pi r squared. 4x all cubed simplified. 4 cubed is? 64x cubed. And 3/4 of 16. 1/4 of 16?
4.
So 3/4? 12. Mark the number. Slayed you. What happened? Which one caused the difficulty? 4x all cubed. Okay, don't forget, if you've got that situation where something is all cubed, both the numerical coefficient as well as the variable has to be cubed. Yeah? So what does 4 cubed mean? 4 multiplied by itself 3 times. So 4 4s are 16 times 4, 64. Okay, 9, 8, and less than 8. Okay, any questions about them? All right, here's the story. My wife bakes chocolate chip cookies, which I like. But lately, the number of cookies, or the number of chocolate chips in the cookie, has been decreasing. We're going to simulate an experiment here whereby we have to find out how many chocolate chips I've got to put into a mixture to create 6 cookies, which you have on that sheet that I've given you, so that I can be pretty sure that each cookie is going to end up with at least 3. Yes? Now, anyone got any ideas as to how many chocolate chips I would have to put into my mixture so that I would end up with at least 3 in each cookie? 18. What about if I had 18? Now they're mixed up in this mixture for the 6 cookies. Are you sure that each time you scoop out some of that mixture you're going to get 3? So you're riding on the bare minimum there, aren't you? you're hoping that you're going to get 3 each scoop. What we're going to do is this little simulation exercise, and it's just to gather some statistical data so we can carry on with our statistics. You're going to work in pairs. One person's going to roll the dice. The number of the dice indicates the cookie, and your cookies are numbered 1 to 6. For example, if I rolled a 5, that means I've got 1 chocolate chip for cookie number 5. You're going to have to roll the dice sufficient times to end up with a minimum of 3 chocolate chips in each cookie. Do you understand? Okay. Tam, I'll help you, seeing you. Who's away today? Renee, thank you. All right. So you know what to do? One person's rolling the die. Each time that number comes up, you put a stroke into your cookie. Now, it may be that you end up with 10 chocolate chips in cookie number 5. That doesn't matter. Okay, here we go. 3. 1. 5. 5. 1. 1. 4. 2. 6. 5. 1. Can you continue? Do you understand what you're doing? Good. Don't forget you've got to end up with a minimum of 3 in each. Roll it quickly. We want to get this data together. Roll it faster. Roll it quickly. We want to get this data. Would you roll it properly, please? Roll it properly.
Sorry.
Hurry up, get your cookies done. I've got it. Who's finished? You must keep rolling until every cookie has got 3 chocolate chips in it.
Our dice has got all these dots where the...
Don't worry, continue. No, not yet. Hurry up, Josh, you're going to be last group. Who's finished? Well done. Any group not? Once you have finished, count up the total number of cookies, or sorry, the total number of chocolate chips that you required to get 3 chocolate chips into each cookie. Mitch, have you finished?
No, we're unlucky.
Okay, let's have those results, please. We'll go around the classroom. Thanks, girls. 25.
27. 22.
David?
33. 42. 36. 25.
29.
28. 31. 25.
26.
And 10? 33. Okay, Rebecca, a bit different from the 16 or the 18 that you originally said. What I want you to do now, they're all the results, okay? From our experiment, I want you to now draw up a frequency distribution table. They're your scores. Do your frequency. 43. Thank you. They are your scores, yes. Come on, just get it done quickly, thanks. Get the rest of your table completed. Don't forget your headings, Jack. Is there anyone who hasn't completed the frequency column? Come on, hurry up. Would you just check your frequency column, see if you agree with this? Otherwise, your results will be wrong. Who had 1, 3, 1, 1, 1, 1, 1, 1, 2, 1 and 1? Yeah. And sigma F will be? 14, correct. Okay, get the other two columns complete. You can use your calculator. What's up, Jokes? You're looking on his. What's the problem? All right. Anyone not completed the FX column? You finding multiplying by 1 and 2 difficult? Oh, you're adding it, okay. Okay, let's just check the FX column. 22, 75, 26, 27, 28, 29, 31, 33, 72, 42 and 43. Agreed? 428 as sigma fx. Thank you. Anyone not completed the cumulative frequency column? Here we go. 1, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. When you have completed that cumulative frequency column, what should you check? Josh?
That the last number in the cumulative frequency column is equal to sigma f, is equal to
Sigma f, good. Okay, would you now find for me the 3 points of central tendency, please? Finished, Josh? Is there anyone else having difficulty with the median? Okay, just stop what you're doing, listen in for a moment, please. What is the median score? The middle score. How many pieces of data do we have? 14 pieces. Okay, now think of it. 14 pieces of data balanced. How many on each side? Have we got any piece of data for the centre? So we haven't got an actual median, which is one of our pieces of data. What are we going to have to do?
Get the 7th and 8th piece of data average together and divide them by
Find their average. Okay? Do you understand that, girls? So this, if it requires a decimal, certainly. Well, how many pieces of data on each side? How many pieces of data altogether? 14. So how many on each side? So numbers 1 through 2 and from? Okay, Tam. How'd you calculate the mean? 428 over 14. To 2 decimal places, 35 was it? Sorry?
30.57.
Thank you. 30.57. Who had 30.57 as the mean? Anyone not?
I didn't get that's a fraction, 34.7.
Fine. Okay, the median, the middle score, which is the one we were talking about. Alyssa, what was the 7th score?
28.
Who used the cumulative frequency column to find it? Good, so we came down to the 7th score, found it to be 28, down to the 8th score, 29. The average of 28 and 29? Who had 28.5 as the median? Good, and the mode. What is the mode? Okay, and what is that? 25. Good. Who had all 3 points correct? Well done. All right, now let's look at that 5-number summary. Right? The 5-number summary. What is the 5-number summary, Kath?
The lowest score.
Yes?
The median, the upper quartile, and the high score.
Correct. Would you find those, please? Certainly. Yep. Right. Finding the lower quartile. Well, remember the lower quartile is going to be the midpoint of that lower range. Yeah? So, have we used one of those pieces of data to obtain this median? No. So all pieces of data in that lower range are in play. So how many pieces are there? Well, how many pieces of data did I have altogether?
22.
How many pieces of data? 14. Right, so how many on each side? 7. Now we use the 7th and 8th to generate that median, yeah? But we haven't used a piece of data, one of our pieces of data, as the median, have we? It was the average of those two. So the 7th and 8th piece of data is still in play.
So you do 1 to 7.
1 to 7. So what is the midpoint there? That's it. Anybody else having trouble finding the 1st and 3rd quartile? Listen in. Listen in then. Don't forget when we were finding the median, we had the full 14 pieces of data, yes? Data numbers 1 to 7 on the right hand side, we moved the 7th and 8th piece of data in to find the median. Now we haven't used one of our pieces of data as the actual median, have we? We found the average of the 7th and 8th piece. Therefore, the 7th and 8th piece of data can still remain in play when we are trying to find the 1st and 3rd quartile. So how many pieces of data do I now have on the right hand side? 1 to 7. And the lower quartile is going to be the midpoint of that of data pieces 1 to 7. So you now look for the 4th piece of data. Anyone not finished? Okay, let's have a look, please. Michael. Low score.
22.
Lower quartile.
25.
Median.
28.5.
Upper quartile.
36.
And the high score.
43.
Who agrees with Michael? Well done. Would you now construct a box plot? A box and whisker plot. Yes. Yep. No, you first of all are going to have to draw up your own scale, aren't you? Now, is your scale going to start at 0? If it does, imagine the length of the scale that you're going to need, right? So we are going to break that scale, and where do you think you'd started? Low score of 22, high score of 43. 21? You could start it at 22 if you wish. Yeah? Miles?
So you said just then we could start from 10 and end at say 43.
Yes?
Or we could start at 1 or end at 50 if you want.
You could, but think of all that wasted scale and how long that scale is going to be on your pad so that you can then fit.
It'd be better for about 20 to 45.
Yes.
Okay.
Yeah, definitely. Now you may have to turn your book on its side rather than going across the page to get a suitable scale. Yep.
When you're doing the bottom line thing,
Yes.
do you put like 36 twice and 25 3 times on the scale, or do you?
No, your scale is just going to indicate those individual scores, isn't it? Yeah? So you start, what range are you looking at? What's the range that you're going to show on your scale?
21.
21. So you're going from 21 up to?
43.
43. So you start at 21, 21, 22, 23, all the way up to 43.
Okay.
Yeah? Yep.
So after we've got to this point, do we just draw a line?
Draw in the box, yeah?
Yep.
That's it. Yes. Why would it? No particular reason. It's just that you're not going to start your actual plot right on the extremities of your scale. Right? Don't forget, once you have completed drawing your plot, then you must show those 5 points on that scale. Yes?
Is this correct?
Looks all right? Looks all right to me. Yep.
How to do it, how to make the box plot. Do you put down here?
Well,
1 to 44?
you could go across here because you've got plenty of room. You're going to need a line showing a scale from. Now, what range are you going to use? Now, you've got to, on your plot, you're going to have to show those 5 numbers, yes? Now, low score of 22, high score of 43. So your scale must incorporate those numbers, at least. And what I'm saying is there any need to include from 0 up to 22 on your scale? There's not, is it? So you might just start at 20 and go up to 45.
Oh, so it doesn't have to be 2.
You could start at 22 and go to 43. All I'm saying is that, you know, rather than have your plot start on the extremity of your scale and finish on the extremity of your scale, you could have a little bit each side.
Oh, okay.
Was I supposed to have drawn all the 23, 24, 25?
No, you don't have to, but that is the reason why when we do these box plots, yeah, you show those 5 points on the scale. You mark them as actual points, because it's going to be very difficult with a scale like that to actually determine what the exact median, for example, is.
So that's not right.
Yes, that's right. But you now have to show what scale, the scale that you used on the actual line there, don't you? So what scale did you use? Where did you start?
Anyway.
Did you start at 22?
Yep, 22.
Okay, so you might go up in, say, 2s, 22, 24, 26, 28, 30, all the way up to 44. Yeah?
Okay. So we don't put the mean and the meridian, only the 5 points.
That's correct.
Okay.
Yep. Your box plot is created using that 5-number summary. You don't need to show the mean or the mode. That looks all right? Yes? But now you've got to show what these actual points are, right? Look, let me just run through that with you again. Watch in, please. If you have created your scale, and your scale is starting at 20 and going up to 44, right? So you put your increments in here, say each of those increments is worth 2. So we've got 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44. Okay, so that was the scale that you elected to use, let's say. We then mark on that our 5-number summary. 22, there it is. 25, well, if that's 24 and that's 26, 25 is going to be right in the middle. 28.5, if that's 29, 28.5 is going to be there. You understand what I'm doing? 36, an easy one to locate, and 43. 43 is going to be there. We then draw in the box, show the whisker, yes? And then, so that anybody else looking at our graph is able to determine the exact values of those 5 points, we mark those, normally above the line, on the scale. So we've got 22. What is this point here? 25. Put in a dotted line down. 25. This point here?
36.
That's a bit wonky. What was that point there? 28.5. This one?
36.
And the last? Now there is no doubt what each of those points is. You agree?
Yeah.
Anybody got any questions? Yes?
If you just told them the range, will you be able to determine all of the other values?
Sorry, say that again.
If you just told them the range, will they be able to figure out the other values?
Well, what is the range?
30.
Beg your pardon?
Oh no. High school minus 13.
High score minus low score. So what is the range? 21. Now, how is that going to help them determine what the 5-point summary is? Right? And like if I had drawn that like so, and hadn't marked those individual values on the scale, who's to say whether that is 28.5 or 28.6? Do you follow what I mean? So we want you to show the exact value, 28.5, above your scale line. Okay. Yes?
Is this right?
That looks good. Yes. All right, let's check, see how we go. Would you pass one to each person, please? 10. Here, Josh.
Yes, please.
One each, thanks. Now don't do anything with your calculators until we all get started, please.
Yeah, is this right as well?
I'm just adding a couple of factors.
Where have you indicated the exact value of that point?
Oh, so we have to write it in.
Above the line, yeah, at there. So that is 28.5. That's it for all 5 points. That's it. That's it. Is there anybody without a calculator? All right, let's have a look and see if we can get our calculators to verify what we've done. Take the cover off your calculator.
Clear all the stuff in.
Just wait. We'll all do it together. That way we'll get to the end. Okay, at this stage you've got nothing on your screen, right? Press the on button, bottom left hand corner. If you've got any statistical data already there, press clear and have your flashing cursor top left hand corner. Everyone at that stage?
Yes.
Would you go to stats, press the stats key. Everyone got that screen? Press enter. Up arrow so that the cursor is on L1. Clear and enter. You have now deleted all information from list 1. Yes? Right hand arrow, bring the cursor onto L2. Clear and enter. Left hand arrow, bringing your cursor back to L1. Let's now enter our data. This is the data we're going to work on. Your chocolate chip cookie one, right? And just before we go on there, how many chocolate chips do you think you would need to ensure that you ended up with 3?
12 million.
At least?
There was no way you could tell because all of the cookies, all of the chips.
12 million.
Well, let's face it, you know, if we put these chocolate chips into the mixture and mix them around, we would expect them to get mixed a little bit and not sit in one corner, wouldn't we? Right? But using the information that we gathered from that little thing. 29? So where are you getting these figures from? The mean? Okay. Let's just have a look at those 3 numbers again. A mean of 30.57, a median of 28.5 and a mode of 25. So you're electing, in this case, to use the mean. Why? Why did you select the mean rather than the mode, for example? Yep.
Because that's on an average of
Yeah.
Yeah, because it's the largest number to give you a chance.
Okay, so you're going to select the larger number and just ensure that you're going to end up with the 3. Yeah? What about if you were a chocolate chip cookie manufacturer, yeah, and you were looking at ensuring that every cookie had 3 chocolate chips in it?
You'd make a separate batch for each one, for each cookie.
You're joking.
Mix up the pan, mix up the dough,
Yeah.
or whatever, put it on the pan, and then put 3 things in each one.
Oh, I see. Okay. But what about if all of the ingredients were all mixed in? Which I've got no doubt they are, because when you buy those chocolate chip cookies, they don't all have the same number. There's no fella sitting there poking in the same number of chips, is there? So all of the ingredients are mixed together, and they would have some quality control and quantity control to ensure that there are a minimum number of chocolate chips.
They're based on weight. What they do is they say each cookie weighs say X number of grams.
Yeah.
If it's under, then what they do is they just mix it up so that even if it's a different size or shape, it still weighs the same.
So are you telling me that they weigh every cookie?
Yep. Yeah. After that.
I doubt it.
Well, that's what they do.
My
That's
dad
what
says they do.
Yeah?
He's a quality manufacturer.
Is he?
Quality systems.
Yeah?
And
What?
they have to-
Where they make these chocolate chip cookies?
Yeah.
Oh, go on. Is he?
No, he does different companies.
Okay.
He's done it.
Home brewery.
In your home situation, most likely you would look at the 30.57, yeah? If you were a bulk manufacturer of these things and you wish to ensure that you had them, I guess the 30.57, which you'd take as 30 or 31, would be the number that you'd pick. There were a couple of scores there, like the 42 and the 43, that Mitch, and who got the 42? Okay. Those two scores seem very high compared to the rest, yes? And we are not going to have time to enter this data and check it. So, second function, on. Put the covers back onto your calculators. Beg your pardon? Yes, thanks. Yep. We'll be back at school here before the buses leave. We'll be back about 3 o'clock. Just wait, thank you. Just wait. I want to make sure that every calculator has been brought back. Is there anybody who has not returned their calculator? That's it. Have a nice weekend, people. You can keep those. Bring them back in on Monday. Bring those sheets back in on Monday, please. Yeah, bring them back and we'll just continue with that.
So we can get technically the calculator.
Yes, we will.
Oh, sorry, sir.
Hello, Nick.
Michael, you're just going to help this man take his gear over to J Block. Too late. Rest of you outside. I've got to do it. Liam outside, thank you.
You found a better candidate.
Oh, don't tell me that, Zach.
No,